Thank you, Prashant, for setting a nice premise for logical continuation for user studio. With conversational AI, we set context for bots, and then with language studio and cognitive services suite for language, we will see what advanced NLP operations we can do here. All right. So a big thanks to the sponsors, and this is about me. You can reach out to me on my Twitter handle, which is at fuzzymind1, right? And yep, so this is how the session will flow today. We will have a throwback to Azure NLP, like some of the previous offerings and how they are bundled into Language Studio. Then we will, of course, see about Language Studio. We will see about Cognitive Language Services Suite and what is the furor of OpenAI GPT, right? And then, of course, the entire session will be interspersed with demos, right? So it's not a specific place at the end of the session or anywhere where we will have a demo. So demo will be there throughout the course of the session. And please, at any time, please feel free to interrupt and ask your questions or put them out in the chat window. All right. So when we throw back to Azure NLP, right? What is this current talk about all the language studio and cognitive services for language? So we already had a lot of language offerings out there by Microsoft, which was first of all, like when we were building a bot framework, of course, how to sort of get a hang of the natural language conversation, for which we had LUIS, fondly called as Louis, and they had a portal called as Louis.ai, which was a language understanding integration services. Okay, of course, as Prashant already mentioned, we had QnA Maker, which is a answering bot. And then we had text analytics, wherein we could extract insights from the text, do a key phrase and keywords extraction, do entity linking, and extract personally identifiable entities like celebrities, landmarks, names of people, and places, geographical locations. Correct. So these were some of the offerings which are already prevalent with Azure. Okay, then why come up with something like Language Studio, or why come up with something like a different suite for language services, right? So we'll shortly see that. But before we go, just a quick refresher, right? So these are the cognitive services, and when we specifically concentrate on language, these were the language services. We had language understanding, text analytics, Q&A maker, text translator, could be from speech to text, text to speech, right? Speak recognition, speech translation, language translation, right? Neural language translation. So language detection, so detecting the language, whether English or Deutsch or French and stuff like that, right? So these were the original offerings, and most of them are still intact, bundled together, offered on a common platform. And of course, there's much more offerings apart from just the ones which we see here. It's a continuously evolving platform as well. Okay, so when we are talking of advanced NLP, right? So why advanced NLP? So as we can see, we are in the middle of a shift from just search driven to an intelligent enterprise, meaning like people are no longer interested in just searching keywords from their documents. They want to extract insights about what they are searching. Even your routine searches which we do on our social media, Netflix, Amazon, whatever you search, you immediately get a knowledge mining graph of who all has viewed the recommendations around who has already viewed this or seen this film, and which are the films or genres based on what you are surfing, searching, right? So same way goes for organizations as well. So here is a real life instance wherein we were working on some intelligent enterprise for a semiconductor client or semiconductor industry. All right, and then the expectation was we will just give you like maybe whatever 100,000 documents which we have, and then you index them into your search engine, and the search engine should be able to do on the fly entity detection, like extract all the key entities, right? Classify the documents, like some may be talking about ion batteries, some may be talking about renewable energy, some may be talking about some other themes. So should be document classification. And then when I search for, let's say, lithium batteries, I should also be be given ionic batteries. I should also be given, people who searched electric cars should also search for Tesla. Or since you search electric car, I think you're also interested in documents mentioning Tesla, right? If I'm searching for solar energy, it should also give me, searches for renewable energy, green energy, global warming, those sort of relevant, interlinked, semantically similar themes, right? So which is why there is always a evolving need to explore the existing language models and make them more perfect, make them more human, right? And because the problem is that the data is exploding. So data explosion means there is more time spent in searching, and then people typically will just guess the keywords. So if you go by your normal keyword key phrase extraction, typically there's a need to have an exact keyword match, right? So I'm searching for, say, government, or I am searching for something like energy efficiency, government energy efficiency projects. So I should be able to just absolutely hit the exact terms. What if semantically similar terms are there but not the exact terms? Okay, so let's say if I'm searching for renewable energy projects in Australia, so my documents need not have Australia, but it could be something like, solar water project, solar energy project in Brisbane, or water conservation, rainwater harvesting project in Queensland, right? So these are still, synonyms to Australia, proximity search, what we call as. So not all the time you're going to hit the exact keyword and or have the exact keyword, and you should be still able to do a lot of things and still try to bring the relevant search results, right? So this is the typical ability to analyze and analysis gap. So as the data increases, data explodes, the gap between analyzing and ability to analyze it kind of increases, which is where we have this pressing need to have a lot of advanced analytics, a lot of language modeling to bring our NLP to the next level, to make it as human, as natural as possible, okay, as fluent as possible. So what are the typical enterprise challenges with data, right? So how do enterprises enable their workers to be a part of this intelligent enterprises, all encompassing, all knowing enterprise, right? So improved collaboration, right? Like, like-minded people doing like-minded work or searches to be grouped together, right? Intuitive interfaces. So which means I need not tell the user, like, go here, go there. So looking at the UI itself, the user should be able to sort of, run through the functionality autonomously. Okay, personalized content search, of course. I mean, that is what, social media is all about. All your data is all about personalizing, right? Consolidating content platforms, so bringing all your data from disparate data sources together. And then, of course, this question always persists, right? What else? Like, what next? What next? Okay, so there are a lot of interesting suggestions around this what else. Okay, so if you talk of in technical terms, the what else or what next questions typically rotate around, revolve around things like, can I convert my natural language into SQL queries? Can I convert my natural language into code, for example? So if I might write very simple I might write a very simple statement like, write a function for in Java or in JavaScript for adding two numbers and return an integer. So it should be able to understand this human written text and interpret it, and then try to be able to compose a function in the language of choice like JavaScript or Java or C sharp, right? And this is what GitHub gave us a functionality of GitHub Copilot. So I will demonstrate that functionality also, right? Then there are other needs, like, for example, summarizing your document. So what happens typically for this functionality is for medical papers or technical white papers, wherein you have a lot of complex content, jargons, and then it has to be sort of summarized in a very efficient and very lucid way for the user to understand. So how do you do dynamic summarization, right? Deep entity linking. So let's say, I am doing a sort of again, we'll see that demo, which is what we built. So let's say I'm extracting information about all the music and artists understand the genre which they play, right? So hard rock, metallic rock, and those things, right? And then I should be able to sort of have relationship between the entities. So this artist plays this instrument, belongs to this genre, or featured in this album, right? So this is deep entity linking or extracting relationship between entities. So this is again another need for classifying documents, and telling me, how the documents or entities are related with each other for me to have a knowledge graph of my knowledge base, right? So whenever we look at knowledge finding or knowledge mining or intelligent enterprises with the AI, it covers a whole wide array of use cases, right? Infographing, meaning you're of course visualizing in the form of graphs or in the form of some dashboards, Power BI dashboards. Grouping content together like text classification, which is what we are going to look into today. Okay. NLP, solving natural language problems. Social collaboration, right? Best information, meaning get the most relevant and most concise, precise information in your blink of an eye. Suggest next best action, like if you search for this document, the logical next step would also be people who search this document also looked at XYZ documents. Auto crawling, meaning once I know how to gather one type of information, so let's say my AI knows how to go and scourge information for weather data, it should also be able to do the same thing for getting, for example, football scores or tennis scores. Okay. And expert search, so meaning getting the most relevant personalized content for that particular search term or for that particular user, right? And then this could be done on a lot of content, like could be enterprise specific internal documents, it could be open source web content, it could be internal databases, company specific, enterprise specific, or your public data, which is public reports, which is published for ESG sort of things, right? And social content, so your Twitter and your Amazon and all those social media good stuff. Okay. So now what happens is in my past sessions we have discussed about advances in natural language processing with the help of BERT. Okay, so with the help of BERT, with the help of OpenAI GPT, correct? And then Azure Cognitive Services for Language is a evolving platform, so it's updated quite routinely. Okay, and then what is basically does is it provides, of course, a cloud-based platform for all the NLP which we discussed, right? So text summarization, text classification, text moderation, text translation, text analytics, also extracting the named entities, linking entities, deep linking entities, all of those good stuff which was already there. Okay, and then all the good stuff which was introduced by the advances in OpenAI API, OpenAI GPT-3. So OpenAI API, if you've got a chance, or people who've got a chance to go through that, I think it's a gated access right now. So not all the people, even for the cognitive services for language, right? Not all the people have access. It's in preview. Some of the features like text summarization and custom text classification are in preview, and it's gated access, so you need to request for the access for OpenAI, and it would be granted to you. So you will typically be put in a wait list, and then it will be granted to you sooner or later, depending on the need for your organization and your queue number, right? So this language service, what it does is it unifies your previous language services offerings, right? So it unifies text analytics, it unifies QnA Maker, and it unifies Louis, as well as it gives you new features which are either pre-configured, so meaning using existing AI models, and then you use them as it is, either via REST API or via the language studio, and then send your data, get the output, or customizable, meaning you can train your model, your custom model with the platform, and then we then use our custom trained model to do all the inferencing. All right. Okay. So this is about the language studio. So this is, of course, state of the art capabilities, pre-configured, customizable, multilingual model. So I'll show you shortly, like when the language studio, you can choose the model, whether, it has to be only in English or can be multilingual. Okay. And then for people who are quite familiar with the custom AI, custom vision AI platform, right, where we have a very nice interface to sort of import images and train images. Quite the similar thing we experience also in Language Studio, where you will be able to extract data, where you'll be able to import data, and where you'll be able to train, test, evaluate, and deploy your models via UI, right? So you click, you click train and then you click deploy. We'll see all those things. And then, of course, security is guaranteed. So our data stays safe. It's only used for model training. It's not stored on the cloud, and it's not the security of the data is not compromised, right? All right. So before we go on to the Language Studio, right, I would want to show you, before we delve into any more details on the Language Studio, I would want to show you a few of the features of Language Studio, right? So let us go here. First of all, before we start using Language Studio, we need to create a language resource. It's better that you create it directly, from the Azure portal. So I have this AI subscription, Azure subscription, and I create a resource. You can directly go and type language resource. See here, language service, right? So you should be able to create a language service resource. There is a lot of, how should I say, terms you need to agree for responsible AI, of course, right? So responsible AI, explainable AI, meaning the information you are sort of uploading should not be compromised, and no personally identifiable information will be stored, and all of those things. So you need to check those terms and conditions for the responsible AI once you create the resource. And once you're there, like once you've created the language service, then we move on to the language.cognitive.azure.com. This is the language studio portal, right? So this is language studio where you can go, okay, and see, for example, when you go to the language studio, this is again in preview function, right? This will be GA shortly after a few of the offerings are perfected, right? So when you go to the language studio, see what all you can do, the features which we're talking about, right? So earlier feature which was already extracting information was extracting personally identifiable entities, key phrases, linking entities, named entities. Health information is something very specific, based on a health model, health trained data set, which also we will see a quick demo for that, how a document summarization takes place, and how knowledge graphs and all, and how dynamic query expansion takes place. Summarizing, so this is all about extracting information. You can these three, extracting P2, key phrases, linked entities, named entities, were existing as a part of your text analytics. Health information and summarizing documents is something of a new offering with the cognitive language services suite. Okay. And then you can classify text, of course, custom classification. Either you have a predefined set of documents, like tags there in some JSON format, typically, and then you have answering questions. So depending on your text corpus, right, if your answer is somewhere there in your documents, then targeted answer, then instead of just searching keywords and key phrases and bringing up the documents, question answering is a very targeted answer to your question, which means it has semantic capabilities. It will understand your question, it will understand the context, the intent, and then accordingly fetch you the correct answers. And understanding conversational language is a part of our LUIS, right? Language understanding integration services, where we have intents and entities, and then you tag the part of speech, and accordingly it is the model is trained, and we are able to make inferences or retrain the model. So these are few of the things which we will see in the course of the demos which are going to be presented today, right? So when we are doing classifying text, in classifying text, we are analyzing sentiment. So sentiment analysis and opinion mining, right? What does this piece of text is talking about. Is it objectionable content, or is it a positive sentiment, negative sentiment? Language detection, which is also already there, detect the language, translate text translation. So these two features were existing previously as a part of the language services text analytics. And now we have a next feature called custom text classification. In answering questions, you have custom question answering. So on your own custom set of documents, you should be able to answer the question. So semantic question analysis. All right. Okay, got this. So we will quickly see a few offerings for a few of these things, right? So let us quickly, first check about extracting health information and summarize documents. Okay, so here is cognitive search for COVID-19 using the health model, or the health COVID-19 health model, right? Wherein we will see also keyword key phrase search, base search. We will see knowledge mining, knowledge graphs, and we will also see how text analytics is used to extract entities on, and tag documents. Okay, so classify documents, tag documents, entities extraction, and we will also see how summarization text, dynamic text summarization takes place. All right, so let us start. Okay, so on the left hand side, the menu which you see here, right? Journal, contributors, diagnosis, these are nothing but entities. Okay, these are nothing but entities for our COVID-19 demo. Okay, so treatment, variants. Okay, and these entities, once the documents are, once the documents are indexed into our search engine, these are the entities which are extracted out. Okay, so let us start with searching, for example, ibuprofen. Yeah, so here it is ibuprofen, and once I say search, then you can see, right, apart from just getting search results for only ibuprofen, it sort of also gives me semantically similar words. Okay, so this is your word semantics. Okay, so what are some of the terms which are similar to ibuprofen, or which are some of the drugs which perform a functionality similar to ibuprofen, right? And then you also have something like next best action recommendations. So find documents like this, documents which are talking of uses of ibuprofen in treating certain symptoms, certain diseases. Okay, and yeah, so and then you also are getting certain for example, certain keywords here. So if you see here, right, coronavirus infection, lung injury, and this which you see, so example, this is the document which was fetched, and this, as you can see, is a dynamic summary of what the document is trying to tell us. So on the fly, we are summarizing the text and also bringing out the keywords from the document. Okay, now if I say, for example, if I click on any other query term, so ibuprofen and NSAID, for example, then the query expansion will take place dynamically, and now you can see my search engine also brings out results of both ibuprofen and NSAID together. So earlier it was just ibuprofen. Now there's a dynamic query expansion, and now I'm getting documents which are talking of both ibuprofen and NSAID together, right? And then as you can see, right, these are the entities which are fetched. So ibuprofen and NSAID featured in which journals, who were the contributors to those journals, what are the body structures which are affected by ibuprofen, NSAID, what is the diagnosis, like the diseases which are symptoms or diseases which are treated by these two drugs, and the names of the examinations. Then like family relations, like can it be administered to children, or all those things, and then genetic information, medical classes, medical medication names, right, symptoms or signs. So all these are a few of the entities which are related to our search results, correct? Right. And same thing, like if you can say like COVID-19, or let's say yeah, okay, 19 symptoms, for example, right? And if I search that, then it will sort of give the documents, and then if you click on search documents like this, it will bring up the related documents. Okay, right? Now what also happens is, organizations will also be interested in understanding the relationships between their data. So once I go to explore graph relationships, I had searched for COVID-19 symptoms. Okay, and then so now based on my search words, okay, I can sort of see the relationship between the entities. So what my entities were: contributors, body structures, diagnosis, all the left hand side, the things which we saw in the earlier page, right? Okay, so now when I'm searching the graph relationships, right, you can see that this is the center node, my search term, and then I'm able to get the primary and the tertiary relationship between my search term and the entities. So let's say, COVID-19 symptoms will give me few search results, few documents. Now, because my entities are contributors, it means that, I'm trying to see that who has authored the documents which are returned as search results for my search term. So maybe COVID-19 symptoms return me like 100 search results, 100 documents, and then these are few of the authors of those documents. And now I'm able to see the primary and the secondary relationship between those. So if you see like COVID-19 symptom and Jin Wang was like, there's a direct relation, meaning few of the documents which were written, author was Jin Wang. But then maybe Jin Wang and Li Zhang had collaborated on another project and written some other document, right? So you can see like I now enterprises are now typically, intelligent businesses are also behind extracting these kind of relationships. So you have COVID-19 symptoms, and you have another, I mean, other terms related to that. Sometimes you could be also returned with unrelated search results, like for example COVID-19 and affiliations, because all this entity extraction is dynamic in nature, right? I mean, how you are extracting entities. So you will be tagging documents and training the model, and then teaching it to extract those entities and the relationship between entities. So it can happen that sometimes you are getting extracting unrelated entities, but more often than not, as you can see, right, it is quite accurate, and it is showing me the second order, third order relationship. So let us check the body structures graph as well, and for our search term, and let's see what it returns, or maybe diagnosis taking some time. Right. So now for diagnosis also, if you see COVID-19 symptoms in the diagnosis, then, for example, respiratory diseases, illness, COVID-19 directly related to pandemics, communicable diseases, and then some of the other things also related to secondary things like hypertensive disease, or infections, comorbidities, right? As you can see. So this is a very informative piece in which I can sort of make a sense of relations between the extracted entities, and try to understand which of them are closely related, or which of them are, yeah, so which of them are sort of interest to me, or what is the structure between my linked entities. Very important, this sort of, knowledge graph, knowledge mining sort of a functionality. So in most of the projects which we do right now, this is one of the features which everyone asks. So apart from your advanced NLP and word semantics and heuristics and all, people typically ask for this knowledge graph functionality, wherein they will be able to understand the relationship between their entities, right? Okay, all right. Now, having said that, right, let us look at some of the more interesting, technically interesting features. So, features which are interesting for the programmers, right? Before we move on to some of the other good stuff. Okay, so all right. So now I was talking of GitHub Copilot, wherein, we were talking of NLP to natural language to code, right? Or NLP to SQL queries, right? So here I will just demonstrate to you. So this is my IoT AI IoT based piece of code, right? And now just depending on the code which I have written, right, it is going to suggest me the next best sort of action I'm going to take even without me typing anything, right? So if I start typing something inadvertently, it will suggest, me the next best thing or the next best property of classes to be written. But let's say I'm not doing anything. I'm just, just sitting there. And even after that, let's say, I had declared I had declared an object here called as obj message, which was of type dynamic. And then I had sort of, declared another property and converted it from some of the, text. And then what it did here was, if you see, it sorry, knew that I have not assigned this object message, and because both of them are of type dynamic, it tried to suggest me that probably you might want to assign obj message here. Okay, right, all right. Or then when we are when we are trying to if it sees that, for example, the previous line is console.write line, it will try to suggest me something similar like console.write line or await something. So if I go here, and if there is nothing, it knows that that piece of code is already complete and there's nothing to suggest, or there's no suggestions which it can give, then it won't return back with anything. So this piece of code is complete. There's no missing assignment, or there is no best action to suggest here, and the GitHub pilot goes quiet, right? The suggestions goes quiet here. But at the same time, if you see, like, for example, if I want to check what I have to do here, and it will tell me, like, I can either accept or reject the suggestion, of course, right? But then it will try to tell me the next best source of action. Or if I start writing something like this, right, console dot, and then it will if I say console dot write line, then yeah, so for example, see, it will try to give me also like, depending on my previous assignments or previous coding statements, it will try to suggest me like what is the next best thing I can do. Apart from that, it can also, as we know, right, give natural language commands to it, and then it will be able to write code. So right now, because I'm operating in C sharp, I had some issues demonstrating that functionality earlier. I don't know, GitHub Pilot is behaving a bit weird for some reason. So that's why I'm not able to demonstrate the code to NLP to code functionality. But nevertheless, this is still something which you can see, depending on your code structure, depending on your declarations, depending on your assignments, it is still trying to suggest you the next best line of code or next best action which you can take, right? Okay, now let us look at one of the more interesting question answering demos, right? So as I was telling you about, right, as I was telling you about one of the demos which we made. So what we did was we collected open source data, Wikipedia data about artists, their albums, and their genre. Okay, sorry, instruments. So probably, like, bands like Beatles, or bands like I don't know, ABBA, Spice Girls, right? And then what were the albums they featured in, or what were the tracks which they played. So we did a sort of collection of all this data, and we had three entities there. We had artists, we had albums, and we had genres. Okay, and based on that, we are doing normal keyword search as well, and something which is called as semantic search. Semantic search meaning, as I said, right, if your answer to the question lies somewhere in your text. So it could be like, I don't know, maybe tens of pages of text, but if your answer lies there somewhere in the hundreds of thousands of documents, it will still try to get a very targeted answer. It will not give you documents, probable documents in which your search term lies, but a very targeted answer to your text. And try to give you some sort of confidence interval. So if I'm saying, are the members of Beatles. Okay. So let's see, if it hits those, I mean, if you can find this answer in the document somewhere, right, it will return to me search result, and then I'll be able to yep. So okay. It's searching, right? So now it came back with an answer and with a score of 99%, right? So with the confidence interval of 99%, and the answer is it will get the Beatles were an English rock band formed in blah blah blah, which is a group was made up of John Lennon, Paul McCartney, George Harrison, Ringo Starr, correct? Or you can also say like what was the genre of the music played by the Beatles, okay? Or what was the genre of the music played by the Spice Girls, and then if it can sort of understand the question and collect the answer from the documents, then that is what your semantic question answering is, right? And that is all made possible by your advances in question answering using OpenAI and also with the help of BERT. Okay, so OpenAI GPT-3 and OpenAI now has their own API by which you can perform all of these good stuff. Okay. So this is what your question answering typically is, and there are like if there are like for example, if I were to show you there are for the music documents. Okay, it's not here, but yeah, for the music demo, there are like probably 200 documents for artists, 200 documents for the tracks or albums, and another 200 documents for the genre which they are playing in. And from all of these thousand odd documents, if your question matches any of the text of that document, it is sort of returning me the result. Okay. Compare this with your average search, wherein you are just going to hit the keywords and key phrases. So if I were to search just ABBA in the search, it will give me all the documents which is sort of which is sort of matching the search results. So if I were to search here Metallica, for example, okay, and then it would just, yeah, for example, so it will hit the documents in which Metallica is mentioned, and then these are the these are the entities as we saw in the COVID-19, right? So we had genre. Okay, so Metallica was mentioned in this hardcore punk and southern rock and groove metal, right? It was featured in these albums. Okay, and these are the artists which are belonging to Metallica, like Led Zeppelin and Iron Maiden and all of those things. And here also we can view the entity map, which is like the relationship between your nodes. Okay, so as you can see here, right? So this is your search term, and then you can select the facets. You can select artist, album, genre, or all of those, and then you can look at the levels. So here we are showing you a three-level hierarchy, like first order, second order, and tertiary relationships as well. You can even go up to 5 levels and then see a more detailed, more deep linked graph for your search term and all of its constituent facets, right? So I can choose just artist and I'll be able to see only the linking between artists, for example. All right. Okay. Yeah, so now I'm just Metallica, and Metallica the direct it's still working. Yeah, so now if you're seeing Metallica, and you can just sort of pull it out here to yeah, and then it Metallica, the direct relationship is Ozzy Osbourne, right? And then Led Zeppelin, and then there are Guns N' Roses, and then there's a second tertiary relationship between Elvis Presley and Guns N' Roses. So can understand like a sort of how your entities are linked and what your data is trying to tell you, what sort of story your data is trying to tell you. Okay, then depending on this, you can also organize based on the most occurring search word or the most linked word in all the documents and all of those good things, right? All of this good stuff. Yeah. Enough of talking about these features. Okay. Now let us look at the actual offering of the Language Studio and why it is such a big deal. What as mentioned, right? So now we are in the Language Studio, and let us try to try to see classified text, and let us also try to see your dynamic summarization. We already saw, right? For example, using the OpenAI functionality of summarization, we saw in the COVID-19 how these documents are dynamically summarized. So when I see find documents like these, right? And there are certain things where you'll have abstract available, and yeah, see for example here. So abstract available, and this abstract available is the dynamic summarization of the documents, which is featured here. Okay, so dynamic summarization is sort of understanding again the context, and then concocting a summary, a human readable lucid summary of your entire text. Okay, on the fly summarization. Now, when we go to conversational language understanding, which forms the crux of your bots, or understanding commands, or understanding spoken text, right? So if let us look at how easy it is to sort of do your language understanding project. So I have already created a project because it takes typically a lot of time to instrument and create entities and stuff, right? So we'll see how very efficient it is to create the entities and intents directly in the portal, and then and tag utterances or train the model. Okay, so what I did was I created three intents, which is this is, let's say, for an email use case. For an email use case, typically my intents will be attach, delete, and read. So I read a email, I delete the email, or I attach certain files to the email. And my entities would be the sender who sent the email, and what is the type of the file attachment, right? So PDF and the name of the file, like save the PDF file with the name PDF dot, I mean something dot PDF or test dot PDF, right? Demo dot PDF. So sender, file type, and file names are my entities. Okay, intents are these attach, delete, and read. Okay, so if you see like tag utterances, okay, then here you have a very intuitive UI. You can select the intent, either of them. So I'm selecting the intent read, and then I am saying read mail from uh, from ABC, something like this. Okay, and then I just click enter, and then you can see tag the entities here. ABC would be of, come on. So here, yeah, here you can see like ABC, this entity, and you can select and tag it, that this is the sender. Okay, so I'm tagging it as ABC is the sender. Okay, and same thing, like if you see attach, right, add the PDF file with the name signed contract, I can actually tag this as the file type, and then this as the name of the file name. So whatever my utterances are nothing but the natural language text which I want to train my language model on, right? So my custom language model, if I want to train it on certain uh, 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 natural language phrases, right? So these are utterances, and entities and intents are nothing but the type of text which I want to derive out from my utterances. Okay, so could be a pizza ordering use case wherein I want to have a margarita pizza. That could be your pizza type, and then of size L, or 10 inch or 12 inch, and that could be the pizza size, pizza type, pizza size, type of toppings. Those could be your entities, and your intents could be order pizza, deliver pizza, receive pizza, or cancel order. Those will be your intents. Okay, and entities, as I said, could be the type of pizza, the topping of the pizza, the size of the pizza, right? Um, and you can tag your, and then your utterances could be like order a margarita pizza which serves 2 to 4 people, and then that margarita will be your pizza name or pizza type, and then serving 2 to 4 people will be the size of the pizza, could be 10 inch, 12 inch, depending on those things, right? So this is how you can easily tag from the UI itself, and then once you are done, you will save your changes. Okay, save changes, and then you will go to the train model. Okay, And in the train model, you will be able to just train. So either you can, so I already trained a model called as LUIS. So you can train a new model because you made some changes, because your inferences were not accurate and you wanted to add more utterances, or you want to add more intents or more entities, and then you train your model. So either you create a new model, okay, or you overwrite your existing model, okay. Once your model is trained, so as you can see, right, for all of the AI trainings, it's an 80-20% split. So 80% of your data will be testing and 20% training, and 20% will be used for testing. And then you will deploy the model. Okay, so whatever model you've trained, you will deploy it, and then you will use it for making tests. Okay, so this is the model which I had trained, as we saw on the read mail use case. Okay, and then we enter our text, or we can upload a file also, and then the result would be shown to us. Okay, so let's say I'm saying, okay, so I'm entering something like extract the PowerPoint file from the mail sent by JSON. Okay, I don't know, it could be accurate, could not be, right? Let us see the results. So it says, the top intent is read, and the entity is sender. Okay, so it was able to identify one of the entities, like, sender is JSON, but it was not able to identify the other things like PowerPoint file. So it was not able to identify the type of file. Okay, so PowerPoint file, or save the PowerPoint file, something like that. So not able to. So maybe I need more utterances in that case, right? And then I will add more utterances there, add more entities or more intents, and then probably, retrain my model again. So as you can see, it's very intuitive, right? And very easy to do that. You can tag your results. You can this is the original text, and then it has given the entities, and then you can also view the model details, by the way. So if you can see here, okay. So you can see the model details, precision, recall, F1 score. So now this was a very small, test demo use case. So that's why typically you can see all of these is quite, accurate, quite precise precision. But normally, if you have a huge text corpus, and a lot of entities and intents, right? If you can see the confusion matrix there, right? So this delete and read and attach and all, and then you can see that this is a confusion matrix: two positives, two negatives, false positives, false negatives, and this would be something of a model explainability, like, how the model is trained, what is the confusion matrix there, how does it classify your utterances, what was the rationality used for classifying, and all of those things, right? So very easy to use, very easy to train your own language models, intents. Okay. Similarly, there's also I know I'm running short of time. I'll make it very quick. So you go to Language Studio, you go to your custom text classification. Okay, classified text here, right? So custom text classification. Custom text classification, you can create a new project. Okay, so the project type could be like, single label, wherein only it is classified either A or B, like, diabetic or non-diabetic, or as only like, news or non-news files, or news or project files, something like that. And multi-class is like more than typically one label, like, movies, if you're trying to classify them as horror and thriller and romance and action and kids animation, those kind of things, right? So this is multi-label classification. So I choose multi-label. I can click next, give all these details here. So of course, you need to create your resource beforehand, right? So here I've already created a language service. Okay, so give some name, some description. Okay, and primary language is English. And then see here, you can still click on yes, enable multilingual dataset, because my dataset can have probably, different languages also, right? So I'm not selecting it currently. And then you will select a blob container. Let me show you what my blob container typically, has here. Okay, so my blob container here has a list of movies. Okay, and containers. Okay, this is my container, and my blob container has a list of movies which I'm going to classify, right? And then I also have a JSON file here which tells me the intents. Okay, so these are the my classification genres: mystery, drama, thriller, comedy, action. Okay, and then this is the name of the file. Okay, and then how it is classified. So here going on 30 is classified as a thriller. Okay, and then scenes from life is is classified as a mystery. Okay, so this is how I'm going to train my file. Okay, and same thing, like once you are once you have these things, okay, you will typically use this as your training data. You will train the model, and then you will give I mean you will give some unseen movie names and try to have it classified as a particular genre, whether mystery or thriller or drama or comedy, right? Again, all by the use of the UI. There's a bug here. So if I see, right, if I create a project. Uh-oh, wait, I didn't, okay, I didn't create it properly. I didn't select the, uh, yep. So anyways, so I didn't select the proper blob storage. Okay, that's why it created an empty project. Okay, but yeah, I mean, you get the hang of it, right? So you can still select, yep, you can still select your existing data, and you can still select. Yeah, no, okay, it created. All right. So, but then it is already, the data is already tagged, right? Yeah, here. So we already know that going on 30 is a mystery, or going off on 30 is for example, it's a mystery here. So I can see it is a tagged or untagged file, and then accordingly I will tag it. Okay. So if I say tagged file, okay, and then I can add a class. Okay, I can add class here like thriller. Done. And I know that now this is tagged as a thriller. Okay, same thing. Like you can have tag all the 200 files, you can train the model, and you can deploy the model and improve the model. Is basically you sort of on the basis of your inferences, you can either say that this is correctly inferred or not correctly inferred, and try to correct the model and then retrain it again, right? So again, very intuitive, directly, a lot of things you can do right from the studio itself. All right. So yeah, this is what the new avatar of Language Studio, I should say. Like Language Studio basically gives you a UI to work on all of the cognitive language offerings, including custom text classification, which is in preview mode, dynamic text summarization, and all of the previous good old things which you had with text analytics and with the QnA Maker and with the language understanding integration services. All right. Yep. So these are the features of Language Studio. It identify important concepts from your text corpus, better understand customer perceptions, right? So what people are searching with the help of the knowledge graph, which I showed you, right? You can easily link that who was searching this search term, and how many, people are directly linked, not directly linked, using, to better understand your customers, then comprehend information faster, right? Automate workflows, meaning, if you had I mean your documents to be classified, you can do the document tagging, and you can have workflows. If you had previous projects with Louis and QnA Maker, you can also sort of connect them using the Language Studio. Process medical text, which we saw using the health model, health specific NLP model, and use a natural NLP conversation with the customers, right? Which can be used in your bots, in your IoT applications, and your web apps, web chat bots, and all of those good things, right? So demos we already saw, and yep. So I'll be open for any questions. With that, I end my presentation.